Okay, so it is 2:30. I'm assuming everybody can hear me. I'll take silence as a yes. Okay, so first off, I want to say y'all did really good on your Mario levels. Congratulations, awesome job. They were all a lot of fun to play through. I left comments on everybody's stuff, so if you go into the assignment and look at the comments, there's a comment about what I liked or what I didn't like or what I think you can work on. In the same vein, those of you who posted it by like probably midnight last night, your 2D game plans, I've made a comment on all of those as well. That again, you've got to go to like the actual assignment page and look at the comments. It's not in the discussion board. And a lot of what that is me saying, well, I think this one might be easier, or I think this one might be more fun to do. Because I know a lot of you are really kind of freaking out about how much programming or how much coding is going to go into your game. And all of you have had pretty good ideas. Some of you have given ideas that are way out of scope. Like, I would love to say that you're going to be able to build everything that you guys want, but you got to remember that you've got a limited time on top of having to do all your other classwork. So keep it simple. That's the answer. Keep it simple. If you can keep it simple and get one mechanic working really well, then once you have that working and once that's done, then you can go and start adding in everything else that you wanted to add in. So in the product world and the software world, it tends to be called the MVP, which we think of as the most valuable player if, you're pretty normal. But in software stuff and in gaming stuff, it's the minimum viable product. So this is what you can get away with it being finished in quotation marks without it having all the bells and whistles. So for this class especially, aim for your MVP and then start adding stuff to make it what you actually want. So look at what I'm requiring for the actual game and figure out what you have to do at minimum. Get that done, then start adding more things. So, and on top of that, y'all have done pretty good with the coding. I mean, it was relatively simple what you guys had to do last week, but believe it or not, Unity coding is not too bad. So what are we going to talk about today? Today we are going to talk about sprites. Today we are going to talk about making them move on your screen, not animating, moving. So like if you press the left or right arrow key, it goes left or right. Interacting with things, so maybe you want to push a boulder around, or conceivably even if you wanted something to pick up when you touched it or disappear when you touched it. And then we're going to talk about physics, which has kind of everything to do with moving, but also nothing to do with moving, because Unity actually allows you to either use the physics engine or not use the physics engine to move. So it's really kind of up to you and up in the air, and if you Google which one is better to do with 2D, you will find lots of people who disagree. So I will show you both. I tend to like using physics only because it already gives you gravity, so you don't have to worry about programming in gravity and things like that. So, and that's kind of important when you're doing things like a platformer. Gravity helps things. So, okay, with that said, what we're going to be covering today... I'm sorry, did you have a question? Uh-huh. I literally do not take attendance. Y'all could show up or not show up. I won't know. The only thing I care about is you guys finishing assignments, so that's why I record all the lectures. Yeah, if you don't like sitting here at 2:30 and have something better to do, go do something better. Yeah. No, I 100% I get that. But just in case that hasn't been made clear to everybody, if, don't worry too much about being here in person. Being here in person, it's nice because it means you can ask questions, but it's not, I don't take attendance. Yeah, they're all. It should be. Generally, I get it up within like 3 hours of the end of class. It just kind of depends on internet. So yeah, it'll be up tonight. Okay. Okay. Cool. Cool. Bye. So yeah. Today we're gonna talk about sprites. If you are wanting to follow along, we're gonna be using this one first, and basically the Unity project that you're using for this, you're going to use for a lot of assignments up till like midterm, because what we're going to do is we're going to start building on this one Unity file. So we'll import backgrounds, we'll import a sprite, then we'll animate that sprite, then we'll take it a bit further where we're switching scenes, and basically just builds on top of each other. And this is just because, so honestly, I like those kinds of assignments because you feel like it's progressing, and so you can kind of see where it could become a game. Some people don't like them because you feel like you're going to be graded on like past mistakes, which I will never do, by the way. If you've managed to mess something up and I haven't graded it, and then I get to the next assignment and it's still messed up in your file when you submit it to me, that's not what I'm grading on. I'm grading on the current skill. So, please don't feel like... I hope at this point you guys know that I'm not like crazy about grading. I'll get a little bit harder with your actual games, but in general, I'm pretty lax when it comes to grades. So, because I get that this is a lot of stuff being thrown at you, so you do something, I'm pretty happy. Okay, so with that said, if you are following along, you do need to download this using sprites zip. It's very small. It's incredibly small because it's just images. So, with that said, once that's all done, you're gonna have, wherever Unity happens, there's Unity, and it's gonna look like this. This is what's inside this using sprites thing. It's Betty, Boulder, Rusty Crate, and Viridian City. Yes, that Viridian City, and no, if you don't know what I'm talking about, we're talking about Pokemon. So, to get these into your Unity project, there's a bunch of different ways, which we've talked about before. You can drag them like directly into the file, you can drag them directly over here, you can use the import assets. My favorite way is either to drag them from here and just put them in. So right now I have a sprites folder, and see, they're now inside of here. So, or like I said, you can actually come over and you can copy these, and then you can find wherever your file is. I don't actually know. Desktop. Okay, cool. So you can come over into your desktop. You can find your folder. You can go to assets. You can go to sprites, and then you can paste them in here. That's a whole other option. Those are the two options that I like. I don't like using the asset import option, which you come over here and you right click and you import. So, import new asset. I don't like using that one just because it seems it's easier to drag and drop. It really is. So, once we have them in here, we haven't really used this side thing over here, this inspector. And that's where we're going to start using it a lot more today. You may have used it when you were in your Mario because you did stuff with variables and things like that. Yeah, mad props to those of you who went and messed with those kinds of things and like made the camera work a little bit better, or changed some speeds, or yeah, did stuff like that. Cool job. I didn't show you how to do that, so extra cool job. Mainly because I didn't want you to be too overwhelmed. So, first thing we're going to look at is we're going to look at Viridian City. And when we click it, you're going to notice that there's this little arrow next to it, and that's just telling you that this is a different kind of object. When you click Viridian City, though, anytime you import an image, it's going to have some different texture types for it. And if you scroll down, it's going to list all these things. When we're working in 2D, we will pretty much always, and I say pretty much always, it's going to be, yeah, almost always, like 99% of the time always, be with this sprite option. So in Unity, well, okay, in general, when you think of the word sprite, a lot of people think of, oh, that's, you know, a character image, or a moving character. In Unity, they deal with anything that's 2D, that's used on a 2D plane, is a sprite. So just note that sprite just means an image. When we get to 3D, the texture shape can change. And then the other thing that's important is you have this thing called sprite mode. And sprite mode says, hey, am I just one image? Which we know it's not, because this is all broken up into different things, and you can see. So it's got 1, 2, 3, 4, 5, 6, 7, 8 different images. So it's not. The same with if we looked at Betty. Betty is broken up into however many that is. 4 by 4, so 16. So that's where you've got to change that kind of thing. Let me see if I'm getting ahead of myself. Okay, no, I'm not. And then pixels per unit is one of those weird things, and I'll show you how to do that. But pixel per unit definitely, it refers to how many pixels there are in a unit. So if you, it's how to scale a sprite without actually having to use like the scale handles. And that comes in really handy when you have a bunch of sprites that maybe have the same they're using the same sprite pack, and so you want to scale them all uniformly. And this is how you can also get things to be more pixelated. Not the best way to do that, but it is a way to do that. So after that, you have mesh type, which it deals with how much bleed or overhang is around the image. If you need to have bleed or overhang around the image, you're generally not going to mess with this one. Like, generally you're not going to mess with it. And then extrude edges works with that. And then the pivot is literally, where do you want the pivot? Generally speaking, pivots get put in the center for background objects, but for like characters and things, especially once you switch over to the 3D world, you tend to put them down at their feet, because that's what you're wanting to snap to, like the top of a brick or to something else. So use it to where it's your advantage. That's basically, yeah. Then generate physics. If you wanted to generate physics, you click the button. If you don't, then you don't. So after we skip through all this, you can ignore all of this advanced stuff. I guess the only ones that are kind of alpha source, so if you have a map, alpha is transparency. For those that don't know, alpha is transparency. For those that don't know, alpha is transparency. So generally you're going to have, if you import a PNG, which again I'm going to stress, PNGs are your best friend, JPEGs are awful. PNGs are your best friend as far as like the base types. We could get into Targa and all those other guys, but if you're looking at, you have a PNG or a JPEG, PNG is always your best friend. Unless you need something to be compressed to hell, and then JPEG is fine. So when you're using a PNG, they tend to have an alpha map already, or they have a transparency on them. So you just use that one. You can also import from grayscale, which is a little bit more difficult, but yeah. And that's, you know, if you need to have no transparency, but you have a PNG that has transparency, you click this guy. And then MIP mapping. MIP mapping is a weird beast, and if you may or may not have already seen it, it's where when you look at a texture map for something, it does weird bleed all over the place. So like the image looks like it's been stretched around the edges. What do I have that I can show you? Because I realize that may or may not make sense. Let's try... Black and white isn't going to be a good example. Her. Okay, so MIP mapping. Those of you who have seen texture maps on 3D models, as long as this will let me view the 3D maps, or the 2D maps. So, generally, you know that your mesh is cut into pieces. And when you look at the texture maps, like, you can tell that this is all, so if we turn on the wireframe, you can see that this is the only part of the mushroom that's the mushroom cap. But we have all this stuff that's bled out to the edges. What mip mapping does, and it works for 2D and 3D, more for 3D than 2D, but it can affect 2D if you're messing with vertices. But so for 3D, what happens is that occasionally your mesh can go one direction and your textures can go the opposite. So we mip map to make sure that if the texture or the model accidentally shifts in the different direction from the model or the texture, that you don't lose what it's actually supposed to look like. So you bleed all these edges over. And it can look really weird. Sometimes it doesn't, like this one, you can see it doesn't really do it, and that's because this is a transparency cutout. And then sometimes it's like really crazy, and sometimes it gets, you know, really creepy. So that's what mip mapping is. And if you don't know, the site that I'm on is called Sketchfab. Sketchfab is a great place, especially for artists. It's kind of like DeviantArt and to a lesser extent ArtStation, but specifically for 3D models. So it lets you post your 3D models, and it even has a marketplace. It even has all sorts of other things. So yeah, those of you who took me over summer, you've seen this. Those of you who have never taken me haven't seen this. So yeah, it's a great place. Okay, so that's mip mapping. That's the only one that's kind of important. But you really shouldn't have to worry about any of these advanced settings. The next thing that you're going to want to worry about is this wrap mode. Wrap mode is basically, do I repeat? If you want something, oh, let's go back to Radiant City. If you want something to have a repeat, you tell it to repeat. If you want to have a mirror, you mirror it. Mirror once per axis. This is great, especially when you're doing like backgrounds and maybe you have just one picture of a brick and you want to mirror that brick all over the place. And then filter mode. Filter mode is super, super important, especially if you are doing pixel art, which I know a lot of people are super fans of. If you are doing pixel art, bilinear and trilinear are not your friends. So what bilinear and trilinear does is that it kind of softens the edges. It tries to smooth things out so that it gives the appearance of not having any kind of pixelated edging. So that's great when you're trying to put a photo up or when you're trying to do like really nice art. I'm not saying that pixel art's not nice art, but like, you know, things that have smooth edges anyways. If you are trying to do a game that has pixel art, you must change it over to this point filter. So to actually show you that, so, and this may or may not be easy to see. So this is with it set at bilinear. Yeah. And you're not really going to see a difference between bilinear and trilinear. So we'll apply it. So it doesn't really, you don't see a difference. However, if we switch over to point, can you see how clear those trees got now? Point, bilinear. Point, bilinear. Okay. So this is exactly, that's how I like to equate it. So when you have pixel art, when you have things that need to have really crisp edging, you have to have the point filter. And then whenever we make any changes, we always want to click apply. You can see that this is actually like changing as we're doing, but if we were to go off of it, it would actually revert it. So we want to apply. And the kind of cool thing is, you mess with that by using these, by clicking these guys. But any that you put in here, all of the import settings are going to be from this guy. So I can put like 8 of these in here, and they're all going to affect like whatever I do down here. So if I was to put, let's turn this guy off, a boulder in and then duplicate it. Remember, Control D is duplicate. And we were to just move these guys around. And we're like, oh darn it, these are way too small. I need them to be bigger. You know, this is where, again, this is where the pixel per inch is going to be like really helpful, because, you know, we could literally sit there and grab like this guy and be like, okay, so I need to do this, or we could manipulate here and then press all the numbers. But what we can also do is come down here to this boulder and say, yeah, that's not going to help me. Let me make it 25 pixels per unit. And we click apply. And all of our boulders scale for us. Wow. Yeah, so all of our boulders scale for us. So that's one of the nice things about the difference between here and here. So it's kind of the same way that we talked about a parent-child thing. It's kind of the same way. This is the master. This is the parent that controls everybody. But you can also say, come in here and be like, yeah, well, I want this one to be like this, and I want this one to be like that. So that's kind of how that works. Okay, so let me switch this guy back over to 100, because otherwise I'm going to be very confused. So, back to Viridian City. So we know that this whole filter mode is really important. The next thing that's important to look at is this max size thing. So, what this says is Unity's saying, hey, I'm going to try and scale this so that it fits within this size. And while this is super important for bigger images, it's also important for smaller images, so to get it to match what it needs to be. And now you're going to notice that these are all, if you guys are programmers, these numbers look familiar. Even if you're not programmers, these numbers probably look familiar. You're probably used to things that are 64 by 64 or 128. Or even when we're talking your hard drives and your SSDs and your externals, 256, 512, 1024. So what these are called, these are the powers of 2. So it's basically 2 to 2, 2 to 4, you know, so on and so forth. Or I guess 2 to 2, 2 to 3, etc., etc., etc. So in the programming world, these are your best friends. This goes also to your images. Your computer will compress things less. Yep, and this is why. Your computer will compress things less if it is in a power of 2, because that's directly readable into binary. Basically. That's a really shortcut to that thing. But basically, your computer will read them better when you're looking at these numbers. I mean, to be fair, textures don't have to be powers of 2. Neither do UVs. You will find some that are ridiculously strangely sized. But the base programs like Maya and things like that, they don't make it easy to make them not powers of 2. So when you have a weird image like this, which is technically, if we were in the 3D world, a texture, but we're in the 2D world, so it's a sprite, it's down here, it tells you it's 784 by 1301. So what we need to do is we need to say, hey, what's the max size on this? And we pick whatever is the closest number to the largest size. In this case, it's 2048, because we can't go under, we have to be over. So this one's fine, but say if we go into this rusty crate is a 32 by 32. We don't need it to be 2048 by 2048. We'd switch it all the way down to 32 by 32. So that's kind of how that works. So the other nice thing about this kind of stuff is that when you're looking at the resizing, you don't need to worry about this. Format, you can leave it automatic. Again, if you guys really want to go look at all this stuff, go right ahead, but it's not super important. Yeah, it's really not important. And then compression, depending on how much time you want to save on your game, you can switch things over to low quality, or you can switch them up to high quality to be better. Generally, normal quality does okay. And then you have this special thing that says use crunch compression. Crunch compression saves space, but it has to be in multiples of 4. And that's kind of what this one talks about, but yeah. So like this one wouldn't be applicable, but maybe the other ones would. I don't tend to use crunch compression for these kinds of things, and you won't generally use it until you get way down the line, maybe not even in your game sim, because it's not always helpful, and it can cause some problems with how images like look. So yeah. So are there any questions on one other thing. You can affect multiple things at the same time. So if we grab all 4 of these, because we know all of these are pixel art, we can come up here and say we want to make sure that the filter mode for everybody is a point, and apply. And it's now applied to all of them. So like that's, it's a really nice thing. It's a really nice thing. So okay, any questions so far on that? On importing sprites? Okay, I'll take silence as a no. So I talked about the fact that we've got this whole idea that we can do single or multiple sprites. And we're looking at this guy and we're like, hey, that doesn't really fit, does it? We only want one part of this. Maybe we could make this bigger and then we could just kind of hide this stuff. But what we want to do is we want to cut it. So we come back down here to our Viridian City, and in this sprite mode we switch it over to multiple. We click apply, and now you can see that Viridian City has kind of disappeared and it no longer has this little drop down thing. So what do? You may also notice that there's a new button, or maybe an old button, but there's this button that says Sprite Editor. So what we are going to do is we are going to click this one. If this button does not exist, or if when you click it nothing happens, if you go to Window Package Manager, you can search for 2D and install the 2D package. So over here, Window, Asset Management, not Asset Management, Package Manager. And you can find the 2D maps, like the 2D stuff that's in here. So it should be 100%. It should be, unless you manage to uninstall it, because it's standard, but it's possible. I had somebody last year. One of the school computers, or a couple of the school computers, had managed to not download it, so we had to go through and figure it out. It was fun. So this is our sprite editor. Now, when you want to cut up a sprite to be multiple pieces, we don't call it cut, we call it slicing. This is also one of the ways that having 2 screens is like really, really helpful, but we'll deal with it. Like, I'm currently working on 3 screens, so this is pretty good. So there's a few different ways to like actually slice things and get things to be what you want. The easiest way, the like best, happiest, wonderful way to do it, if you click this little button that says slice, there are options here. You can have automatic, which will try and figure out for you what it needs to be. You can have grid by cell size, if you know the number of cells. So this will be perfect for like Betty, so our character. If you know that there are 16 cells, so you know that it's 4 by 4, or grid by cell size, if you know how big those cells are going to be. So if you know it's 64 by 64, you can set those up. Or if you know, again, if you knew that there was 16 cells, you know that there's 4 columns by 4 rows. But for this one, we may try automatic. And you can resize things after everything, so don't worry too much about like getting it perfect the first go around. Um, and you can choose where your pivot's going to be. Again, we talked about this. And you can even customize your pivot. Because we don't really need to worry about these snapping together or anything, I'm just going to leave it in the center. And then you have this whole thing that says method. You don't need to worry too much about this. Delete existing. If you're slicing on top of another slice, it'll delete everything that you've sliced before. Smart will try and do its thing. Safe, again, will try and do its thing. They don't always work so great. So we've got automatic, and we click slice. And I don't know if you guys can see it. I guess you guys can probably. You can see this little white border around things. That's where it's sliced. You can really see it here. I promise it exists. Like you can see. You can see here where it's sliced. You can see around these corners where it's sliced. And to get around here, to move around here, it's the center wheel mouse clicked and drag. And then to scroll in and out, it's just the wheel. So yeah, if you click the left key, it's going to make a new slice. And if you click the right key, it'll also move. I just like, because everything else is with the middle key, I just do the middle mouse button drag. So yeah, so we've sliced everything. If you click these things, you're going to see it's sliced everything. And they're actually pretty good slices. The only one that, well, I mean, this one's even good too because we've got that. But we know we don't need these guys. So to delete things, you just click it and press delete. Click and delete. Click and delete. So now these aren't included in our slices. To make your life easy, you can also rename things. So maybe I want to rename this Viridian City proper or City Square or whatever you want to name it. And don't feel like you have to name everything right away. I like to because otherwise I forget. And then that's what the Poke Center, or not the Poke Center, the Pokemart. This is a classroom. I don't remember what that is. And then we know that this is the upstairs of the Poke Center. Okay, or I know that that's that. I'm sorry, I'm a nerd. I mean, I'm not sorry I'm a nerd, but yeah. So we've renamed all these. And once we're done with doing the naming or changing whatever we want, like maybe we want to change the pivot points, we can then click apply. And now nothing looks different, but if we come over here, we now have our arrow back under Viridian City. And if you click the arrow, well, look at that. We've got all of our different objects. So if we click the X button here, and now you see that this object doesn't work anymore. So we're just going to delete that guy out, pressing the delete key. And we're going to take and we're going to say, hey, I want the city square. So we're going to put the city square in, and ta-da, we have a city square. Like, who knew? Like, that's, I mean, okay, we all knew. Wow, we all knew. So, yeah, so now we have our background. Now, because this is working off of a Game Boy screen, you notice that this is our play screen. So this white border right here. There's no way that this is going to scale to fit that, right? When it comes to doing things, if you come over to your game tab and you click down here, the one that's going to be the closest is going to be a 5:4 screen. So, and you can see, like, we still, it's not quite scaled like it should be. So the next thing that we're going to do is we're going to actually go in. I talked about this whole pixel per unit kind of thing. And yeah, you may be tempted to sit here and shift and make this, you know, fit like you want it to. And that looks pretty, you know. But the best option is going to be so that we can scale everything that's in this Viridian City object. Like, we want to scale everything so that it's the same. Is going to be to come up to Viridian City and mess around with this pixel per unit. Because I've done this before multiple times, 62 tends to be right around the right spot. And if we click apply, you can see it's just a little bit bigger. So when we come into game, we now see that it fits the whole screen. Yeah. So that's pixel per unit. And it also means now that all of these guys also have that same pixel per unit, so that they're going to be, like, they're now going to look the same if you pull those in as well. And, yeah. So the next thing that is on this document, if you are looking at the document too, is that I have you guys slicing Betty, but since this class works a little weird and it's not one of those I can just, or it's going to be easy for me to stop and sit there for 5 minutes and then be like, you guys good, you guys good, I'm going to go ahead and walk through slicing Betty. Again, if you've got to go back and do it, you've got to go back and do it later, or you can do it with me. So we're going to slice Betty. We're going to come up to Betty, and we're going to click, we're going to say, hey, it's not a single, it's a multiple. We're going to apply it. We're going to come to our sprite editor. So, and this is one of those ways that you can decide, do you want to say that you have 16 cells, or do you want to say that it needs to be automatic? And you can see that there's going to be slightly different. So if we slice it this way, it slices that way. Whereas if we slice it this way, it's going to give her a lot of extra room. And it's kind of up to you which one you want to do. So my opinion, I like having less room around her, so I 100% would do automatic. And I would maybe go to bottom and see whether that works. So, and then you can leave her with these numbers, Betty 0, etc., etc. Or if you want to cut down work for yourself later down the line, you may rename them. So this is Betty front, and then you can call it 0 or 1 depending on whether you're a programmer or not. How did I name that one? Betty front. So this will make your life easier when it comes to animation. But the setup's a little bit more. And then for this one, we would call it and again, it's up to you whether you want to take this time, because at the end people aren't going to see these individual names, but it definitely helps when you're trying to set up animations down the line. And for this one you may call it down, or you may call it front. For this one you may call it up, and you may call it back. It again depends on what kind of game you're making as to what you're doing. I called the other one, so back. And sometimes people just call these R and L. I don't know. I like writing them all the way out for this part. I don't know why. Don't ask me. I can't tell you. Maybe because it's easier for me to see on like a quick glance that says right and left rather than missing just a single letter. Yeah. So we got all those renamed. We can click apply. And now when we exit out of this, again, Betty now has all of her options. What are you? Huh. Okay. So let's see. 0, 1, 2, left, 1, 0. Again, if you manage to not, because apparently I managed to not get these right, you gotta come back into your... What are you doing? Go away. You gotta come back into your sprite editor, and that's what you're gonna rename. So, 3 notes left. And that's probably because I managed to name something twice the same thing. And the other one was back. Okay. Apply. Okay. Really? Why? Okay. Okay, that would be why. Forgive me because apparently I've got sticky fingers. Okay. Why? Cool. So now, see, now they're all in order, and it's easy for us to be able to figure out 0, 1, 2, 3, 4, blah, 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 blah. And that'll come back to be helpful when you're doing animation. Maybe not as helpful now, but helpful with animation. So, if you drag Betty in, and I'm just going to drag her front, there's a couple things that are going to be a problem. One is that she's kind of hiding behind everything, but 2, also that she's really, really tiny. So the first thing I'm going to take care of is the fact that she's really tiny. Like, she should probably be a little bit bigger. Like, not by much, but a little bit bigger. So I have found that the best thing in the world to do for her is to switch her to 85. Now you may notice, and this is something that confuses a lot of people, the smaller the number is, the bigger the object is. The bigger the number is, the smaller the object is. And this has to do with, because think of it like a box. So a unit is one of these squares right here. And when we have 100 in here, that's our normal basic standard. If we want it to be bigger, we're going to fit less of those little things in there. So we need it to be a smaller number. So when we can fit 85, let's say, okay, so if we can fit, we've got a box and we've got cats. Why we're putting cats in a box, I don't know, but it sounds like torture. So if you want a box to fit 2 cats, it needs to be one size. If you make the box smaller, or the cats bigger, let's go with that. If we got kittens, we have a box of kittens. As they get bigger, less cats fit in the box. Does that make sense? Schrodinger's cat, yes. But basically, as the cats get bigger, less cats fit in the box. Sorry, I've got like 3 other people walking around and giving me things at the same time, so I'm so sorry if I sound really confused. trying to pay attention to everybody because everybody's home today. And yeah, it's one of those days. So yeah, so the smaller the number, the bigger the thing is. The bigger the number, the smaller it is. And we can see that if we switch this over to 85 and we click apply, she got a little bit bigger. If we switch this to, like, I don't know, 200, she got super tiny. So 85 tends to be the good point for her. It means that she can show. I don't know that her fat head would actually fit through these doors, but we're in a hypothetical video game world, so it doesn't really matter. So yeah, so the first thing again that you probably notice if we zero this back out is that you can't see her. And one, it's because we got this camera icon right there, and maybe we want to turn that off. So you can take and turn that off by using your gizmo button, and finding the camera if it really, really bothers you. Or that one's not going to actually turn that one off. Cool, but it shouldn't really be that big of a deal because once we scroll in, we can, yeah. So we can find out that she's there because, you know, you can see all that stuff. But where exactly is she? Now, the issue with that is because Unity works on order of layers. And basically, when you shove everything in and you don't tell it what the order of the layers is, it creates its own little arbitrary order. So sometimes even like taking and putting this one above it, like you can see, it didn't actually fix it. And sometimes if we were to go to the game mode, it didn't happen this time, but sometimes even if you go to the game mode, suddenly they'll switch order. And that's just because Unity likes to play with RNG. So, yeah. So, to fix this, there's a few different ways you can do this. You've got this button right here, those of you who have already seen it, it's right there. And that's great. And you can like set numeric values, so you can say that this is 0, this is -1, because you can go negative and suddenly, yay! But the issue with this is that then you have to remember what everybody's numeric order is and what happens if you want this one thing to between these other two things and you've already put like 100 things into your scene. The answer is you cry and you fix numbers. But the way easier way to do this is that you have this thing called sorting layers. And right now you can see we only have one. But we can add some other layers. Like we can say, hey, and the ones that are generally the ones that you see are going to be background, or the ones that you're going to use are going to be background, midground, sometimes enemies, player, foreground, and then sometimes you'll see one more that's like drops or items, and generally this one is before foregrounds. So, and literally the easiest way to do this is to just drag it. And the great thing about this is that it works in that order. So this is a thing that will always be in the back, this is a thing that will be a little bit in front, 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 a little bit in front. So this makes your life so much easier. And you can see there's some layers too. We don't really have to worry about this, but there are also user layers. And we'll talk about those a little bit better. And we'll talk about tags as well a little bit later. You've seen tags if you looked at the coins or things like that inside of Mario. But we'll come back to that. So if we come back in here, and let's set this back to 0. And remember, we can't figure out. But if we set this one to background, and we come and we set Betty to our player, but bam, she's on top. And no longer do we have to worry about any of those little kind of pesky figuring out which number is where. So Yeah. Sorting layers are your best friend. They make life easier, and it's a lot better than having to remember or having to move numbers every single time. So, and remember, you can add layers, like anytime you go to add a layer, you can actually, anything that's going to be like a sprite, you can start adding them. You can start adding sorting layers in, because it completely like kicks you out of everything and goes to a new tab for sorting layers. And then once you've added things, you have to come back and like actually assign things. So, yeah. So now we've got Betty on our background with our camera icon being our camera icon. That's not what I want. Okay, I'll figure that out in a minute. Cause yeah, that button should have fixed that. I probably clicked the wrong one. Yeah, that should fix that. Okay, there we go. That one? No, you're not? Okay, cool. Cool. It's literally just one button, and I can never remember which button it happens to be because I don't tend to mess with it. So yeah, so now we have Betty on a background. Things are great. It's beautiful. Yay. You know. Now the next thing we gotta do is we gotta get Betty moving, right? That's, the next thing that should happen. So the first thing I'm gonna do is I'm gonna make sure that I save this. And so I'm in my main scene. Just remember to put her somewhere, or put it into a scene that you like. I realized that I should have told you that at the beginning. But I'm just using the first, if you haven't started or if you're not following along, I'm just using the very first project that we made, which is perfectly fine. Just build up on that. No need to just kind of leave it there. So the next thing we're going to talk about is we're going to talk about moving. I think we're going to talk about moving. Yeah, so we're going to talk about moving. And so I have this document for you. And there are 6 different ways that you can move your character in this document. And these are all scripts. And they are all for you. Because the reality is that if you guys go into the asset store or look online, you're going to find character controllers. And you're going to find this already written for you in like 800 million different ways. So we are going to walk through what each of these mean and what each of these do. But I wanted to give you a place that had some really basic bare bone versions. And they all have comments in them, so if you click them and you want to actually read, all of this is commenting. So non-physics movement script using get access raw. It talks about why I use it, what the cons and the pros are. All of the variables or anything that's written has a comment on it to tell you what exactly is happening. So, yeah. And I try to supply these kinds of things for y'all because I get that code is not easy for everybody, and there's a good chance that 90% of you are just going to Google something anyways and use whatever you find without knowing what it's doing. You know it does what you need it to do, you don't know why it does it. And that's, it's an okay thing. It's an okay thing, but it's not the greatest thing in the world to do. So, yeah. So these are some of those. I think I need to talk about physics first. Where is my physics document? Files. There should be another document in here, and I don't know why there's not another document in here. If there's not, we'll just wing it. That's fine. Okay, so there's not. Well then while I'm here, I'll show you what happens if you don't manage things correctly. If you really want a horror story. Anytime she switches scenes, she multiplies. because I didn't control her numbers. Yeah. Bad things happen. And y'all will see that. I will explain like how that works later. Okay, so like I was saying before, there are 2 different versions of the way that movement can happen. One is with physics, and one is without. When you have physics, you need things like a rigid body on your character. And when you don't, generally the only thing that people ask you to have is like a collider box, but sometimes you don't even need that. And the easy way to do, like, or to show how this is going to work, the first one that I have, and you can download all of those scripts if you want, click to move. If we drag it onto Betty, and if it works like it's supposed to work, which I totally checked this weekend and then don't remember what was happening with it. You can see it has a speed. If we click the play button, and I haven't messed anything up, it's going to think about it. It's going to say no, yes, it's going to say yes. Okay, so see, we can click and she's moving. Yay! I mean, she's not avoiding obstacles. There's not anything happening. You can see that I have left mouse button pressed, yo, which we learned how to do last week. We learned how to click the button, and then this script actually tells you how to use it. So this is one that you guys may or may not. Some of you guys have talked about a point and click game, or interacting with a point and click, and so some of you may use something like this, and some of you this may not be in any way, shape, or form helpful for you. But I did want to put it in there because it is kind of important to be able to see how that works. Are we going to open? We're not going to open. Okay, cool. We're going to think. Okay, fine. Then I'm going to come over here. Modules. And yeah, so we're probably going to, I'll switch the quiz around, so don't take the quiz too soon, because I think I'm not going to cover everything, and I'm going to shove some stuff to Thursday. Just because I think we're going to do interaction. I'm going to talk about interaction and more about physics on Thursday. So we'll talk about movement, and then I'll switch this guys over to Thursday. That way I'm not keeping you here for 8 million years. This is not the right script. That's not the script I told you. Did I tell you to open that script? Probably. No, I didn't. That one. Okay, here we go. Moving with the mouse. Again, like I said, everything is commented for you. So this requires nothing special. Just put the script on the sprite and fix whether you want it to follow or on click inside the script. See the directions inside of update. So Vector 2 and Vector 3, we kind of talked about these, and y'all were terrified by them when you did your intro programming lessons. A Vector 2 is just an X and a Y position. A Vector 3 is just an XYZ position. You can use Vector 2s and you can use Vector 3s inside of 2D as well as 3D, and sometimes you have to use both. When it comes to using a mouse, mice take a Vector 3 for specific reasons, because why not? And all this is doing is we're saying, hey, we've got a public float speed, so we're saying how fast do we want our character to be moving. And we give this a public because it means that we can fix that in the inspector. Remember, anytime you have a float, which is just a number with a decimal point, you have to end it with an F. That's how you tell it, yeah, this is a float. And then on start, we say the target position is equal to transform.position, and the target is equal to transform.position. So transform.position. Every object in your scene has what's called a transform. And that holds things like what the position is at, what it's doing, all sorts of things. Just know that its biggest thing is that it holds its X, Y, and Z position. And so in this case, target position, which we know is a vector 2, holds an X and a Y. Whereas target holds an X, Y, and Z. This can also hold scale, it can also hold all sorts of things. It's just a component. Any game object has it. And then you have mouse follow. So where you want to go is equal to the mouse position converted to the world coordinates. Because remember we talked about the fact that when we click, the number that the mouse actually gives off is in pixels, not in the world position, just in the pixel position. So we need to tell it to change that from our normal kind of thing, where the normal kind of pixels, into what it is. So we've got to do this, and just remember you just got to do that. It's just that's what it is. And this is casting. So this is saying, hey, take this, which we know is not a vector 2, and switch it to a vector 2. And then we have to say, if the sprite isn't already at the mouse, move it towards the mouse. So if the mouse position is not at the target position, transform. And this is just how we do our speed. And again, this will make more sense when we walk through some of the other ones. I kind of jumped the gun with pulling this one open first, but yeah. So void update. This set of code will have your sprite move to where you clicked. If you want to switch over to one that just follows your mouse, get rid of all the code in the update section and call mouse follow instead. So we can go ahead and, if we wanted to, we could take all of this away and just call, I can type mouse follow and save it. And when we come back over here and it does its thing, when we click play, she's now following. Yeah, she has a little bit of a lag, but that's because of the speed we gave her. So it means that she's not always right up on the mouse. And you could totally say, hey, if she catches the mouse, have this or this or this happen using that code. So yeah, so that's kind of how that works. And again, I'm sorry, I jumped the gun. This is not one that I should have showed you guys first. So let's go to one that I should have showed you first, which is going to be these non-physics options. So we talked about axis raw, and we talked about just pressing normal keys. And to start with, the third one is probably going to be the one that makes the most sense to you, because the third one is literally using if you press the keys. So let's go ahead and we're going to delete this one off of here. Remove component. I'm going to take this one and I'm going to shove it onto Betty. And you can see that this one has everything built into it. Let's see. Let me see if I have to add anything first. It'll error out, and if it errors out, that's a good thing for us. So it's playing. So now you can see, and you can see even here, it's telling us where her position now is. So she's moving. Oh, right, because that's on there. Let's delete that. So she's moving. And yeah, it's that, sometimes it's that simple when it comes to movement. You just shove something on something. So let's go ahead and open that one so I can show you how that one actually works. And don't feel like if you find a tutorial or you find something that shows you how to do a different way of moving your character, don't feel like you absolutely have to use the way I've showed you, or absolutely have to use the scripts that I've given you. Because the scripts that I've given you, I'm not going to lie, they're not exactly the best and most optimal way to do the movements. They are a way, and they should be relatively easy to understand, but they're not the only way. And there's a lot of places that will show you a lot of different other ways to do it. So what this says, non-physics movement script with get key, string name, and vector 3. So the pros for it, it can define the speed for each key. Fast and easier way to define without having to declare position variables. Vector 3 has a predefined variables for left, right, up, and down. And using the string name for keys is faster than using key code dot blah 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 blah. Which I won't show you. You can look at it if you want, but nah. So you technically don't need to use vector 3 since you're only in 2 dimensions. That's a con, but it's not really the worst thing in the world, like, really. And then because you control each key separately, you end up having to write more, which could be a con. That's like one of the best parts about Git Access, is that you can kind of combine 2 keys into one, or actually you can combine like 3 keys or 6 keys into one. Yeah. So with this, we defined a public speed. Again, it's a float. Remember, floats mean decimal points, and you always have to end it with an F. You can change the speed as it fits in your inspector. We don't need to call anything in start because we're not doing anything in start. But when we get to update, all we have to do is transform our position. So again, we want to take the transform of an object, and in this case, it's what we call this. So if this script is on that object will move. Old school programmers, old school kind of things, you would see it written this way. And now it may actually get angry at me. Name can be simplified. And even older school, it was this dot game object dot transform, something like that. Yeah. But it's understood that if this script is on this thing, that you don't need the this. So this will affect whatever it's on. So the transform, again, that contains a whole bunch of things. So if we come down here and we say transform dot, you'll get a list of things. ToString, the direction, the point, the vector, translate. When it comes to physics, you will never, ever, 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 ever use translate. If you're not using physics, translate is fine. Translate is movement. It's moved from point A to point B. If you're using physics, don't do it. Yeah, just don't do it. Up, world. So it's got all these extra kind of things that you can get. Local position, local rotation. Those are getting your rotations. See if it's a child of something. You have all sorts of things. And this is just a component that's on top of your game object. So just note that the one that you're going to use the most often is going to be the position. So it's pretty much always, this is one to memorize, transform.position. And then you're going to say vector3.left. So when I press the A key, I want to move to the left. So vector3.left. And then I want to move at whatever my speed has been set at. So in this case, it's 2f. And we talked about this last time. Time.delta time. We want to move it at a specific pace. So every X seconds, we want to move it. And we want to move, we want to move it. So that's how we standardize that. And that's just the same for everything except that we change which direction we're moving in. We're moving right, we're moving up, we're moving down. And if you're doing a platformer, it's kind of the same way. Maybe you don't need all of these. Now, remember that generally you want to make sure that your input is going to work for people who either use the arrow keys or use WASD. And to do that, remember we've got this little OR sign. We would do OR input.get key, and we would say left And when we save that, we can now actually use the left arrow key if play will work. There we go. We can use the left arrow key, which I know you guys can't see, or we can use the A. Now we haven't set any of the other keys, so the other keys don't work. But we can use WASD to move around, and then we can use the left arrow key. So that's kind of, that's how that works. Is it the smartest way to do it? It is a way to do it, and there is no shame in doing it that way, because this is like the absolute easiest way to do it. When it comes to, actually I guess I will show you. I'll run through this one real quick. So this one does it a different way too. So instead of using the left and right, it uses position, so just changing the position. And this is another way that you'll see it. So you're going to get the position of your thing, which doesn't rely on your transform. Because transform has a position, well, it does rely on your position because we've set it here, but it does it in a slightly different way, insofar as it just gets the Y or the X, and that's how that does it. And you can combine or change or mix these if they work better for you. It's kind of up to what you want to do. So yeah, and this is kind of the big one. Setting the position afterwards means that you're sure. So because what this does is it says, hey, check if the key was pressed, change this position. If these was pressed, change this position. So it gets all of the changes in the position. So like if you're pressing the left and the up key at the same time, and then it transforms. So it doesn't actually calculate the transform or the position change until after it checks all the keys. Whereas when we're going with like this one, it technically does this first, and then it does this, and then it does this, and then it does this. So if you're pressing two keys at the same time, it prioritizes one over the other. Okay, are there any questions about this so far? Does it make sense or does it not make sense? Okay, because it's okay. If it doesn't make sense, it's okay. I get it. And sometimes it takes playing around with this, or sometimes it takes asking me questions, and please do ask questions if it doesn't make sense. Because I get that these are weird words. What is a vector 2? Vector 2 just means an x, comma, y position. So a vector 3 means an x, y, and z position. A vector 2 means an x and y position. That's the only difference between the two of them. Also, this is about as complicated as the vector math that I'm going to make you guys do. So, because I know that was another big kind of question that you guys had, or fear that you had on your intro programming stuff, was whether you were going to have to do vector math. Yes and no. So, can we use vector 2 instead of vector 3 to move? Depends. It really depends on what calls for what. So, in this case, the only reason why we're using vector 3 is because vector 2 doesn't have these directions. So, vector 2 uses this one. So, vector 2, you have to adjust the y and the x. Whereas with vector 3, it has an option for doing left, right, up, and down. So if you were to do this, to switch this to vector 2, you would just switch this over to like, let's see, vector, you would use just like vector 2 dot x. It would be, or dot, not that way, it would be vector 2 dot Oh no, it wouldn't be that way. You'd have to do a couple other things, but basically it would be, yeah, you kind of work it out to vector2.position.x blah 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 blah. So when you're doing it this way, it's just easier to do it in vector3.left, and then you just don't worry about that third axis. So if you want to do left, right, up, down, you've got to use vector 3. If you want to do x and y, you use vector 2 or vector 3. It's really a whichever one you feel like using. Okay. So yeah, and like I'm saying, this is like the most extreme version of vector math that I'm gonna make you guys use. So yeah. There may be a little bit more when it comes to 3D because we're talking about acceleration and stuff like that, and those of you who talked about doing things like racing games or games that need acceleration, you may do a little bit more, but not by much. Definitely not by much. Because I get it. For a lot of y'all, math is absolutely terrifying. So the one difference when it comes to axis, which is the way that I honestly like to do it, because look how many lines of code there are. It's just that. It's just those 3 lines versus all of that or all of that. This is it. When we're using this thing called getAxisRaw. And again, getAxisRaw literally says if you use the arrow keys, WASD, or your joystick on a controller, work with this stuff. So this is the one that I'm pretty sure this is the one that I use for a lot of other things for y'all, because it's a lot easier to remember this. So up here it talks about it condenses the number of lines you have to write. It means that whether you press A, the left arrow, or the left on the joystick, you're covered. Now the cons. I know there's a lot of words here. What getAxisRaw does is it works on a range of -1 to +1. And this is so if you're pressing a joystick, when you're like halfway in the middle or halfway between like 0 and -1, so between being smack in the center, like a basic joystick, and moving slightly to the left, you move slower. Or it gives like a 0.5 for that number. Whereas if you're on a keyboard, you literally only have -1, 0, or 1. So you can move slightly slower if it's coded that way with a joystick, whereas you only have not moving or moving when it comes to a keyboard. And once you know that that's a thing, and once you understand that that's how that works, you swear when you half press a key down that you're still moving slightly less, but the reality is you're not. Like, it's just your mind tricking you into thinking, oh yeah, that's how it works. No, that's not how it works. That's not how a keyboard works. For those that don't understand how keyboards work, it's literally an electrical impulse that says this key has been pressed. Literally what we've done with the on button press kind of thing, that's how a keyboard works. It says, has this been touched? Yes. It doesn't say, has this been half touched? It just says, if it's touched, register. If it's not touched, don't register. That's all a keyboard says. So that's the big difference between these. So for this one, we've got a couple extra variables. So we have public float. Again, that's our speed. This defines how fast we want to go. Private vector 2 position. So this is this is the current position as well as what you want your new position to be. And I know that sounds confusing, but basically what it says is take the old position and then transform it to the new place we want to be. So to start with, we have to say, hey, what is the first position that we need? And the first position we need is the position that our current object is at. So position equals transform.position. So then, if we want to change the x value, so if we want to move horizontally left or right, we tell it, hey, move left or right, so -1 or +1, and then take the speed that we want, so in this case it's a 2, and then multiply it by the change in time. So that's our time.delta time. And then the same way we say, hey, if we're moving in the y, do the same thing. And then after those two have been changed, take this new value, the new position.x and the new position.y, which are saved into this value right here, and transform our current position to this new place. Does that sort of make sense? Yeah, I've been watching. Yeah, that's one of the reasons why I'm kind of like, I think we're gonna call it a little bit early today, rather than me going into what I was wanting to finish today. Because yeah, there's some crazy stormy stuff going on. Yeah. So we'll get this as close to finished as I can, and then we'll do the interacting and stuff tomorrow. So, or on, not tomorrow, on Thursday. So I will post this video. It shouldn't be much more than maybe 10 or 15 more minutes. And, yeah. So that all of us that are currently watching the skies, don't miss too much out at the end. So basically, yeah, this is the easiest one to memorize, honestly. And again, it works. You just grab it, dump it on Betty. We take this one off. And again, the speed is a 2, which is going to be kind of slow. But now it means if we're pressing A, and you can even do a combination if you want to press A and then the up arrow, it'll move. So the one thing that we haven't really covered is the fact that if you watch, she moves diagonally faster. And I'll let you guys figure that out if you want to change it. But now we can do anything. And if my controller was over here, is my controller over here? This is a lot of cords. Are any of you the cord I need? No? Okay, none of the cord I need. So apparently my controller is not over here. I could have shown you what the controller does. I thought I'd grabbed it, but I guess I didn't. Yeah, so that's the best option, honestly. Now, when we're talking rigid body, we're going to go through this, and then we'll pick up with physics, on Thursday. And I'll change the quiz out, so please don't take the quiz right away, because it's going to have a couple questions that I've got to change out. So, what you may notice is that this looks even easier. This is because you have to add another component onto your character. And it's called a rigid body. So we need to get the rigid body off your character. We have the speed. And then all we have to do is, because a rigid body says, hey, this character has physics, all we got to do is manipulate the physics. So we say new vector 2 is equal to any horizontal input. So if we're pressing the A or the D, the left or the right, or the joysticks. And then any vertical, so up or down, left or right, up or down, W or S. And then we multiply it by the move speed. Now, you may have noticed, I told you guys last time, anything that is physics related goes into fixed update. Because it is in fixed update, we do not have to put time.delta time in here. Because we're already getting that with our fixed update. Because our fixed update, remember, every 0.2 seconds, or every point, 0.2? Yeah, I think it's 0.2. 0.2 or 0.02, it's going. It's firing. It's going and 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 going. Now, if you read up here, it will tell you the script uses physics of velocity attached to a rigid body 2D to move the character. It requires the player to have a collider and a rigid body. If you're doing a top-down, you will need to turn the gravity scale to 0. And because the physics engine takes into account the z-axis, you're going to want to freeze it. So, when we're talking about that, let's go ahead and we're going to remove this guy. If you click Add Component, you can say rigid body. Now, this is going to be something you're going to start running into. There are two options for rigid body. There are two options for colliders. There are two options for triggers. You want, if you are in the 2D world, to be a rigid body 2D. And we'll talk about this stuff on Thursday, what all this stuff means. Just note that for now, constraints, we want to make sure that our gravity scale, because we are a top-down, is 0. Otherwise, she will fall off the world. So, if we switch this over to 1, I think she should fall off the world right now. Notice how she fell off the world? Because she's gravity. There's nothing stopping her from falling off the world. So that's great when you're doing a platformer, but if you're doing a top-down like this, it doesn't work quite that way. So, if we switch this over to a 0, and we take and we want to make sure that we're freezing rotation on the z-axis. If you don't, she will start spinning and go woo off of the screen. Not a fun thing. I mean, it is a fun thing. It's hilarious when it happens. But not a fun thing. So all these other things, again, we'll talk about. Dynamic has to do with whether it's actually moving and doing things. Whereas, and you guys have seen kinematic and static. Yeah, I can show it once we get her all. We may actually be hooked up. So when you come into Betty, I haven't put that script on her, and we want to put this script again, just drag the script onto her. You're going to see that this has a place for the rigid body. You're just going to take this rigid body from here, and you're going to drag it into there. So it may not work because we don't have anything for her to collide with. Sometimes, so it'll definitely happen once she starts colliding with things, and so I'll show you guys about how that works on Thursday. But for now, note that she needs a rigid body. Because she has a rigid body, she technically also needs a collider on her. So always make sure to have your rigid body and then add a component. You want a collider. She can have a box collider, she can have a capsule collider. Capsule colliders tend to be what we use for characters. But in this case, we can just do a box collider 2D. And if you click her, if you edit the collider, where is her collider? Oh, because I'm in the game scene. Ah, that helps. So you can see this is her collider. So this is what's going to bump into things. Maybe we want it to be like, we don't need her hair, or her hair can touch it, and maybe the top of her head can go through stuff. So it's a little bit less of a collider. And that's how you put colliders on things, by the way. So one of your next assignments, and you can start doing this now if you want, even before I show you how to do it, is going to be to add colliders to things. So we can come into the city square and we can add a component, add a box collider 2D, and then you're going to click this edit collider button. And so right now it's this huge thing, but we only want it to cover like maybe, again, edit collider. We only want it to cover like this area. Now, you can do multiple colliders on one object, but then you can't actually really easily target each of the individual colliders. So your best option is going to be not to put the collider on here. It's going to be to create an empty. And then you can move it, again, if you press the W key, you can kind of move it to where you want your collider to start. So in this case, maybe we want it around the Poké Center. So add component, box collider 2D, edit the collider, and we're going to want to move it here and here. And I found that generally you want to move it up a little bit because you want her to be able to kind of walk up to the door and not just like bounce her head off of it. So maybe that's our collider. And this would be a great way to name this one, would be to say, hey, this is the Poké Center collider, or this is the Poké Center, or just Poké Center. Now, when we play, you're going to notice because it's a collider, she can't walk through it. She can walk up to it, but she can't walk through it no matter what I do. So, with that being said, if we unfreeze her rotation, see how she kind of, and sometimes you can get her stuck into rotating. Yeah, there we go. You can get her stuck into rotating forever. And it's kind of great until you realize that it's causing all sorts of problems, like computationally. Because in the background, what that's doing is it's like doing massive crazy stuff to different things. So, yeah. But if you ever have a character that's spinning out of control, check and see if you've frozen your rotations. I mean, now she's frozen that way, but you know. Yeah. So one of the first things that you're going to have to do for your assignment after you get like this all together is that you are going to have to go in and put collider boxes on all these buildings. If you want, you can put it on the trees, you can put it on the lake, and then because I'm sure it's more than just a couple of us that are looking at possible storms, we will go ahead and so the assignment that you would have, well, we'll talk about detecting the mouse with colliders and pushing things around and interacting, which is basically what I showed you, the whole collider thing. That's part of interacting. And we'll be using physics for the rest of this kind of thing. So it's going to make interacting really easy. It's literally as much as you just saying, hey, I'm going to put a boulder in. I want to make it maybe items. I want to add a component. I want to give it a circle collider 2D, which C is already kind of the right size. And then I also want to add a rigid body 2D to it. Remember, we don't want it to fall through the ground, so we're going to take the gravity scale and make it to 0. But maybe we're going to make the mass heavy. And we're going to put the angular drag up. And so now, when we play, if I did that right, boom. Oh no. Come back here. Well, the boulder went away. So basically, you're going to play with those kinds of things, as well as putting colliders and stuff on things. So if you want to, feel free to go ahead and read through the assignment that you would have had for today, which would have been this guy in class pushing things around. So add box colliders to all the triggers, or all the buildings, and then add triggers, which we haven't talked about. So don't worry too much about this, but if you want to get a head start, you can add the box colliders, you can add in the box and the boulder, give them colliders and rigid bodies. You can, again, so because the boulder should technically be rolling anyways, we don't have to constrain the rotation. But for the box, you probably want to. And then you're going to want to edit the mass, the drag, etc., so they don't fly off the screen, like what I just did. And then we'll talk about triggers, as well as the difference between, so like the biggest difference, I showed you how to put a box collider on something, but we'll talk about other different kinds of colliders, but the biggest thing between a collider and a trigger is just this button right here that says is trigger. Wow. And when you make something a trigger, you can walk through it. So if we switch this over to a trigger, she can now walk through the Poké Center without a problem. And then there's all sorts of things written that will let you or all sorts of like methods and things that can make do things. I can talk. They can make things happen when you touch things. So, with that said, are there any questions? Okay. So, I mean, if I was you, my suggestion, because like, yeah, it's getting darker and darker over here, so I'm not keen on frying my computer when the internet goes out and the lights go out. Um, so my suggestion to you guys would be to maybe experiment with the different kind of scripts that I have for you, and then to go in and at least get this set up, like the background and Betty, and add your colliders to your buildings, because then that's one less thing you have to do. If you really want to, the other thing that you can do, so there's the thing that basically was going to be what you were going to do on Thursday, and there wasn't going to be a lot of extra instruction, is this one right here that says in-class mini physics game. You're going to want to download it. Don't worry, don't go here, because for whatever reason it's not working correctly. So download this, and it's going to have some questions here. You may or may not be able to answer all of them at this point, but you can at least start playing around with it. All this is, it's just a basic stack game. It's to show you how physics can work in, like, not a character setting. So if it'll open really quickly, I can show you. Stackamos. And it's built off of a tutorial. Like I said, tutorials are a dime a dozen. It's really easy to find things for everything you need. And it is ridiculously simple. Like, ridiculously simple. But it was meant to show you kind of how else physics works. Why are you opening in that? Okay, cool. We'll see whether it actually works, because this is opening in an older version of Unity, and I didn't think it was in that version. But basically, it will show you. Yeah, it shows you. It's just like it's a basic stacking game, and physics, and okay, it's not even a stacking game. It's a game of animals that are stacked, and your job is to kill the snake without killing the panda bears. That's it. So don't let the panda bears fall, let the snakes fall. But you can 100%, like there's most of these questions, some of them, how many incandescents, you can figure that one out. What items have rigid bodies on them? Try and answer some of these without like actually looking at the file. Like try and figure it out while you're playing. I mean, I'm not going to stop you from looking at the file, but just so that you can start thinking about how this stuff works. Do you think each individual block has a collider on the platform, or could it just be one big collider? Because remember, we can make a collider bigger than just what it needs to be. And then based on how things fall, how many sorting layers do you think the sprites have? Again, we talked about sorting layers. Yeah, that's not going to work. Why are there so many errors? No. But it's just a cute little physics game. The one here you have doesn't have errors. I know it doesn't because I just put that one up for you guys. I was apparently trying to do something with it and downgraded it. So, yeah. So there's a few questions. And extra credit, for those of you who like extra credit, edit the level or duplicate the scene to create a new version of your own. That can be adding in new animals, that can be changing the way that the game plays, that could be making a more complicated stack, anything like that. But again, this isn't really assigned until Thursday. What you guys need to do for sure, or what you should start doing, just because you guys will have an hour and a half of today to work on it, would be to put the colliders on your scene. That's going to be the easiest thing for you guys to do. So, yeah. Yeah. So you're going to add colliders, and I showed you how to add, or what triggers are. So they're just a different version of a collider. So if you want to, you can also add in your trigger or your collider to each doorway. So, are there any questions? Oh, and get me your 2D game plans, discussions. I think when I checked, there were 18 of you who had them in. And remember, due September 10th, reply to 4 others on what you think of their idea, whether you think they're doable in the time frame, any concerns you have, or anything that you think would be cool to add. Do that. Please. Please. Okay. Then with that said, and with storms looming, I will go ahead and let you all go. Feel free to ask me questions, send me messages, whatever you need to do if I didn't make sense today. The tutors are also really great. I don't know who's on tonight, but the tutors are all really great. I do suggest them, but you can always bug me as well. I will be here uploading the recording, and I will change the quiz, so please don't take it right away. I'll message you guys when I have the quiz updated so that it doesn't have questions that you guys haven't run across yet. Okay, so with that said, have a great afternoon, and get me your 2D game plans, start commenting on other people's 2D game plans, maybe set some colliders in the scene. And yeah, I'm going to go ahead and get off mic, so if anybody else has questions, please feel free to ask them. And I will see you guys on Thursday.